useful definition of significant figures is those digits which are known with certainty plus one which may be in doubt. Let's turn to the example of blood alcohol. We have a reported blood alcohol of 0.128 with a standard deviation of 0.0011, which means the value could be anywhere between 0.1291 or 0.1269. It's likely that it's outside of those ranges, which means that this is the digit that's in doubt. So this is our unknown, uncertain significant figure. So it should be reported to three significant figures. What would it mean if we reported it to four significant figures? Let's say we wanted to report it out as 1, 2, 8, 3. Well, that would be academically dishonest. I mean, I don't know if it's criminal, but, you know, it's like, well, we got, the blood alcohol is 0.1283. Well, no, you don't know what it is, you know, to that far out. So it's dishonest. Okay, how about if it's reported out, let's say we round this and report this as 0.13. Let's say they only want two significant figures. They don't want three significant figures. They only want two. Well, my read on that is, I did a lot of work on this, and I come up with three significant figures. They get three significant figures, and if they don't like it, they can round it out themselves. Or, you know, and it's not a cut and dried issue. Let's look at one more example for significant figures. Perhaps the most common analysis done in industrial laboratory settings and even in research settings is an analysis for the percent moisture. Moisture is the inert ingredient, and analysts typically want to know what's going on in absence of the moisture. In other words, without the water, what's going on. It's a very common analysis. The example is you have a moisture of 17.3% water. The standard deviation has been established to be 0.6. Okay, so it's 17.3% water, which would be maybe typical of a piece of bread. 17.3% water. Standard deviation is 0.6, which means there's a 65% chance, 68%, whatever it is, that it's between 16.7 and 17.9. So what's the significant figures? Well, I think you'd have to say that the uncertain digit is the 16, so that this should be reported out as 17 with two significant figures. Nothing is cut and dried in black and white. To me, nothing is ever cut and dried in black and white. If this is, okay, you're doing research or you're in a production situation, you almost could report this out with three significant figures. This raises the question, how is the data going to be used? Is it important to have three significant figures? It's probably not important. Two significant figures is probably fine. If you really want three significant figures, then my interpretation would be that you really need to look at your analysis and figure out some way to tighten it up a little bit. And an easy way to tighten your analysis a little bit is to run duplicates. I think the theme here is to step back from the academics and step back from the rules and take a look at the numbers you generated. Take a look at the use to which they're going to be applied and come up with a realistic, useful number of significant figures.